Okay, just wanted to welcome everybody to the latest ORTC community group meeting. I can't even count the number what we're at anymore, but it's probably like 5 or 6. So just want to remind everybody of the IPR policies that have to do with people, by the way, who are in the conversation. Please just mute yourself while other people are talking. And if you're muted and you want to talk, just press the T button, like T as in Todd, on your computer, and that allows you to talk. Okay. Here we go. So back to the IPR. So the idea here is the community group is open to anybody. Anybody can post the public list, but we can only take contributions and ideas from people who have committed to the IPR policy. So you must join the community group if you want to commit ideas. And the reason is because we can only take ideas that are clear of IPR, and to join the community group requires that you agree to the IPR rules according to the W3C community group. And just welcome everybody aboard. So next slide.
Peter is here, by the way.
He is? Great. That's good news. Okay. So so we're now up to close to, and I was right, 6th meeting. We're up to 80 members now, which is fantastic. Really big group. It's growing fast. And we'd like to bring you up to date in the status of the specification and make some progress on some of the outstanding issues and organize and plan for some implementations to happen. So really exciting stuff. Next slide. So again, I would like to thank Camille for doing this experimental Jitsi Meet. This is our first Jitsi Meet version of this ORTC community group, and we seem to have 20 people in, which is fantastic. 10 people showing, so if your thumbnail is not down there, it's just because there's only 10 people showing, but 20 people in, which is great. And I also wanted to mention that I posted on the list about a week ago, mentioning that I'd like to hand off the chair to Eric, mostly because he's already been doing those duties anyway, and I'm both editor and chair, and I'd rather have a separation between the two roles to make it much clearer, and Eric's already doing that role anyway. And as we grow bigger, it seems to make more sense to really, put some things a little bit more firm. And seems to be really receptive response to that on the list, and lots of +1s. So next time we'll probably have a name change. Well, we will have a name change. I won't be chair. I'll still be editor though. So next slide.
Actually, we want to recruit a scribe for the minutes.
Oh, that's a good point.
Probably 2 volunteers would be good.
So there is a little button at the top where you have the mute, which is shared document. And if you go in there, we really need to have a scribe who can write down some notes as we go along. So is there any volunteers to do that? Can't be me because I'll be talking and I don't multitask very well. And I can give anybody who wants to see the slide deck as to what's going on access to the link in the chat.
So do we need like minuting, or do we need just recording of decisions? Are we recording this overall conference?
We are trying to record overall, but it's experimental recording, and recordings don't always succeed. So we do like to record some, basic notes as we go along. So just general gist of what's going on.
I can record from my side the entire session and give you a kind of a backup video for later on, if you like.
That would be fantastic. Anybody who wants to do backup video.
I'll do then.
Okay, but
basic notes on decisions would be good. If you can do more, that's great. But
so John has volunteered to do some scribing for us. So don't worry about spelling and stuff like that. We'll correct it all later.
Okay, I'm recording starting now, so from now on you got a second copy of it.
Okay, perfect. Okay, so next slide, I'll let Emil describe what's going on here. Let's see.
Right. So I first thank you all for running this ORTC Meet. This is really a great experiment for us. I wanted to tell everyone that there are a few features here that are all still experimental, like the possibility to have bigger conferences where not everyone is being showed. If you encounter any issues, just reload, and if you're going to do any swearing, do it while your page is reloading. And thank you for your patience. Also, if for those of you who want to follow describing, as Robin said, there's the shared document button at the top of the toolbar, and the contact list you can bring out with the buttons at the top, at the lower right corner. I think that's pretty much it. Thanks again for doing this over to me. Bernard, do you want to add something?
Nope, I think that's about it.
I just wanted to say thanks, Emil, for throwing this up for us, and really appreciate that. Thank you.
Our pleasure, and thanks to the rest of the team as well. Robin, you're muted.
Thanks for that, Tom. I didn't realize that. So these are some links for the basic how to reach the community group. I don't want to spend a lot of time on the slide. It's pretty self-evident. I've also got a link in the scribe notes to the actual presentation, the slides itself. We'll put the slides onto the list as well, so it'll all be there. Again, some more associated sites, ortc.org, which gives you your portal to access all of the rest of the sites if you want to have something easy to remember. Issues list. Why don't you take it from here, Bernard, on the issue?
Okay.
Next slide, Eric. Yeah, there you go.
Okay. So there's an editor's draft, which was published on the 14th of October, which is the latest one. So here's a summary of the changes from the public draft. The biggest change was that the object formerly known as the RTC IceListener has been renamed to the RTC IceGatherer, which was issue 150. We'll talk a little bit more about what the IceGatherer does. And then there were a bunch of clarifications. So we had a question about what happens if you call DTLS transport.start more than once, and so we clarified that. We had some questions about the preferred payload type and how that worked within codec capability, and so we added a sentence or two about that. There was some questions about sender.setTrack, which came up in WebRTC 1.0. There was a proposal for a success and failure callback. We did not add that or a promise yet because that issue hasn't been resolved in the 1.0 working group, but we did talk a little bit more about what causes exceptions. So that's now in there. We added a reference on the multiplexing of stun, turn, DTLS, and RTP. Or TCP, there's a 5746 BIS draft, so that's now referenced. There was a question about queuing of candidate events. Basically, when a gatherer gets created, it starts to do its candidate gathering, and so they need to be queued up, and we indicated that. And then there was a question about the behavior of get capabilities when called with a kind, because there are some things, as we'll talk about, some potential codecs like RTX that don't have an intrinsic kind. And so we clarified that.
Okay, so I can talk about this one. So there's been a rename of the RTC IceListener, which we really never had a good name for. And I think it was Peter who proposed calling it the RTC IceGatherer. And so it's just it's a rename of what already existed, and it just makes more sense that the idea behind this thing is to gather all the ICE candidates. And so it's just a much more of a clarification than a real change in functionality. The idea is that the object gathers the candidates, applies your gathering policy, and is responsible for your local stun and turn allocations. And so that's why the on-local candidate is put into this object. So next slide, so we can see the new big picture. Okay, there's the new big picture. So nothing has changed except now that instead of it says the IceListener, it says IceGatherer underneath the Ice Transport. So basically the same thing. It's a no-op operation. Next slide. So those are the changes we did since last time. And I just want to, before we get into discussing the new issues that have come up, I would like to ask, is everybody happy with the general direction of where things are going? And if you have any questions about the spec thus far before we get into new issues.
Hey, Robin, I have a question actually on the previous slide, because it seems that you really fly on a very busy slide. So maybe for, it would be worthwhile for new participants just to give, few more highlights on this one before you move on.
Is that Claudio speaking, or whoever is speaking? Can you announce yourself, please?
Yes, this is Claudio.
Okay, sure. Yeah. Now, I assumed that everybody had known about this, but that's probably not a fair assumption since we got a lot of new people in. Again, this slide is available in the specification itself for those who want to see it again, as well as on the slide deck. So you can definitely go to the ORTC.org to see the whole list. But to give some idea of what's going on here, if you were to take the 1.0 WebRTC and you were to take one level below the peer connection, you would see a lot of these objects are already there behind the scenes. And the idea here is that you can if you want to go from left to right, you take your track, which is your media, either audio or video, you feed it into an RTP sender, which the idea behind the sender is it's responsible for how you're going to encode it on the wire. So it's an object whose entire purpose is to define the encoding mechanism. And that has to wire into the DTLS transport, which is responsible for encryption, so that you can open up a peer-to-peer encrypted session between you and your remote party, which then layers on top of ICE, ICE transport, whose responsibility is, by the way, can someone, whoever is having a little beep in the background, just mute it? It's a little distracting. I don't multitask well, sorry. The ICE transport is responsible for connectivity between you and your remote party. So it does all the stun and turn, all the checking so that you and your remote party can connect together. And it basically opens up the tunnel itself between you and your remote party. On the reverse side, it's exactly the opposite. It's a demux scenario where it first comes into the ICE transport, which demuxes between the different remote participants. And then it goes to the DTLS transport, which decrypts the actual packets from the remote party in a peer-to-peer scenario. And then it goes to the RTP receiver, whose responsibility is to decode the packet to the appropriate media, as well as doing any buffering that's there. And finally outputs your media track, which is your audio video track for rendering on the remote side. I'm not going to go into the data channel part because that's very similar to WebRTC 1.0, so I'm just going to leave that. It's on the presentation just for the sake of clarity, but it's there. As far as the ICE transport and listener, which hang off the bottom, ICE transport controller rather than the IceGatherer. I keep saying listener, but it's not. Got to get used to the new name. The transport controller is responsible for doing the ordering of the stun and ICE checks, because there is an order to that, as well as bandwidth estimation. And the IceGatherer is responsible for gathering the actual candidates off of turn and your stun server, as well as your local candidates, which is used in the ICE transport to do connectivity checks between you and your remote peer. That's it. Okay. Sorry to do that fast, but next slide.
And there are a few things left off, like we don't have the stats API or
it's
like
already a big enough slide. So
yeah, and I think if we wanted to get into a higher level implementation kind of style overview, we might want to do that outside of this meeting.
Yeah,
absolutely. I wasn't asking more than what he did. Maybe as a suggestion, if you could also provide the same big picture before this update, so that would be even more immediate to understand what are the new pieces, what has been changed, things like that.
Yeah, okay. So this is our 6th meeting right now. So the only thing that's changed from the last time is the IceGatherer was renamed from the IceListener.
Okay, so the IceGatherer is the only change, actually.
Yeah, and it's a name change. It's a no-op in terms of operation. It always did what it did before.
Because I saw all this gray and white, and I wasn't sure exactly what was new on that. So thank you for explaining.
The gray and white just, I'm not sure. I think that's probably because it's the difference between the 1.0 and 2.0, what has been introduced. And I'm not sure that's completely accurate anymore, because I think 1.0 is now introduced ice transport, but I'm not completely clear on that yet, whether it's official or not. So
that's exactly right. The gray boxes were supposed to be the new pieces, and the white boxes, the existing, and the grayish ones, the ones that are being currently introduced to 1.0.
okay.
Thank you.
Okay, thanks, Justin, on that. Okay, so next slide. Eric?
I changed the slide. Don't you see it?
No, I still see updated big picture.
No, it's now sitting on coming attractions.
Oh, okay, coming attractions. Okay, now we see it. All right, so we wanted to have the listener and behavior latching rules in this session, and keep promising that for the last 6 sessions. But we've had some issues regarding the RTX, FEC, and red that has come up that's really been apparent. I think that really to be able to define the latching rules, and it still says listener there, we should change that to gatherer. That's how long it's been on the slide deck. We have to get that sorted out, and I'm glad to have Justin in the thing, because he can certainly talk about what they actually do in Chrome, so that we can have it clear, and then we can define the full final latching rules, hopefully.
So it's RTP listener, not IceListener.
Oh, did I say sorry, I'm still waking up. Sorry about that. DTMF and the rest of them, DTMF, IDP, and Datachannel are really tied to the 1.0 spec. So as those progress in 1.0, we're just going to do a one-for-one adoption in our specification, and not try to make any differences if possible. So next slide. So issues for today: updated stats API, section 13. Robustness issues, red, RTX, FEC, automatic scalable video coding, which is one of the issues that brought to the list, and how do we deal with that if we do or do not, and an issue regarding the created associated gatherer, which we'll discuss today, and then we're also going to discuss implementations at the end of their end. That's a missing bullet point. Okay, next slide. There's yeah, there we go. Why don't you talk about this one, Bernard? You did.
So Harold and Varun have created a separate document for the statistics API, and you can access it at the link there. And so the question is how we update the ORTC API draft. And the proposal from Varun was to remove section 13.4 basic, and we'll still have 13.1, 2, and 3, which basically describe how ORTC API uniquely uses the stats objects and accesses them, and then update the enumeration in section 13.3.2 to point to the various relevant sections of the new draft. So most of the stats section would vanish under this proposal, but it would point to the new draft, which I guess is being evolved within the WebRTC working group in W3C. And so that would be a little bit easier to keep up to date rather than trying to copy the stuff into the ORTC API. So the next slide shows you what that enumeration section looks like. And basically there's the inbound RTP statistics, which relates to the receiver object, and you get to that through the RTC inbound RTP stream stats, which is in the section 533 of WebRTC stats. There's the outbound statistics, which relate to the sender object, and that's accessed via RTC outbound RTP stream stats. There's the session, which I guess relates to data channel objects in 1.0. It also relates to peer connection, and that is accessed through the RTC peer connection stats and the RTC data channel stats. And then there's track statistics, which relate to media stream track objects, accessed through RTC media stream track stats. The transport, which I think in our model, maps relates to the RTC DTLS transport object, and you get to that through the RTC transport stats and the RTC certificate stats. There are statistics kept on the candidate pairs that relates to the RTC ICE transport objects. You get to that through the RTC ICE candidate pair stats. And then you can get to the local candidates and remote candidates through the RTC ICE candidate attributes. So I think that's the correct mapping of this enumeration to the various statistics and objects. I don't know if Arun is here and wants to comment, but this is what we're proposing to put in.
Okay, doesn't seem to be here.
So basically a blanket adoption of the stats from this specification. The only question I have is, what do we do with the session stats?
Yeah, probably we should take another pass through this, because I hope this mapping is right. It's may not be 100% correct, but.
So I personally have no objection to blanket adoption. Again, we have to discuss what we do with stats that don't apply to an object that doesn't exist.
Yeah.
My guess is just everything but one object, but I don't know if anybody has any opinion on that.
Yeah, I didn't really see anything that didn't exist per se. It's just, there's obviously a PC object in WebRTC 1.0, so.
So any objections to blanket adoption of the stats in 1.0? You can press the T button to talk, by the way, if you're muted. Allows you to instantly talk. You have to push and hold, push to talk, push to hold, push the T button, hold it, and you can talk, like old walkie-talkies.
Do you want me to talk to this one, Robin?
Sure, it doesn't sound like we have objection on the other.
Okay.
So we'll have to revisit the session object, but aside from that, I think it sounds like a go ahead.
I'd actually like to +1 the other one.
Okay.
Thanks, Emil.
So we had an issue 149, which relates to automatic use of scalable video coding. So one thing that we realized, and I know the document has all these complicated diagrams related to scalable video coding and layering and all these different examples. But in the case where a decoder can decode anything that an encoder can send, which is VP8 with temporal scalability, there's really no need to configure any SVC layering in the receiver. And I guess that's a really good thing, because it is kind of complicated, because basically the decoder can handle anything the encoder can send, so it doesn't really have to know, doesn't have to prepare itself exactly for how the temporal layers will be laid out.
Is that true of all of our codecs that we're adopting for ORTC anyway?
Well, I don't know if I could use the word all, because yeah, I don't know that we can use the word all. I certainly hope. I mean, it's a very nice feature of VP8, and other codecs would do well to try to copy this, but I would hope it would be true. Let me put it that way.
I would hope.
In H.264, we can never quite say whether anybody can decode anything an encoder can send, right? That's kind of the whole problem with it. You can get some pretty weird things. But at least for VP8, it's simple. And that means that if SVC is configured, then basically the receiver can ignore it. It doesn't really matter. There's nothing it needs to know from that configuration. So it's essentially not needed and vestigial. But then the question is, what about the encoder? And we discussed that, and people said, well, you really should turn on SVC explicitly. If the codec can either do it or not do it, like VP8, it shouldn't just happen, because it does have potentially some additional overhead. And so it does need to be turned on explicitly. And then the other question is, for the encoder, is it actually necessary to do all the layers? And in particular, the need for layers can change based on the network conditions. So you might start out with 5 layers and then discover, hey, that I really need to skinny down and just send a base layer or something. So, and the network conditions can change rapidly. So the question is, if the developer just wants to let the browser handle it, which might be a wise thing to do, how does it indicate that? And also, how does it discover if that automatic SVC encoding is supported or not? So that's basically the question.
Let me ask you a question, Bernard. So you were saying that the browser engine is to do this as an application layer, the layering is really difficult because of the changing conditions on the network?
Yeah, I mean, you obviously, you might decide not to do that, but it would probably work better if the browser could probably do a better job, because it could look at the congestion and decide how many layers it should encode. And it would know more about everything. For example, there might be a hardware encoder that might allow it to do more, or, it might be able to react to the congestion certainly faster than the application developer could do by, for example, looking at the stats and trying to figure out what was going on with the different layers. I should also mention that there is a leftover issue in stats. Varun mentioned it, where right now we don't have particularly good statistics on the individual performance of the layers. So even doing that as a developer might be tricky. You might not have everything you'd want. Like, you wouldn't necessarily get a breakdown of the loss within the different layers to make that decision. But in any case, the browser might have that information, and so it could probably do a better job, particularly if the network conditions are changing quickly.
Yeah, so I agree with that the browser needs to make the decision about at any given instant whether a layer should be sent or not, because the application just can't react quickly enough. I do think, though, in a given stream, the application should be able to choose whether or not layering is to be used, because you might not want to use layering for screen sharing, where getting a low-resolution version of the stream might not be useful at all. And so I think there needs to be an explicit sort of configuration of, for a given stream, do you want to use spatial and/or temporal layering? Because I think depending on the content, the application might choose one way or the other. Now, those would just be sort of signals down to the browser saying, for this given stream, this is what I want to do. And if it turns out the network conditions don't allow for it to send full enhancement layering, even if the application has requested it, the browser can make a decision saying that right now I'm only going to send the base layer. But I think the main thing is, if there's an application sharing a stream and the application says, hey, I only want to have a single layer on this, the browser shouldn't try to do anything differently.
Yeah.
So your opinion, just to clarify, Justin, your opinion is that you should still specify all the individual layers, but the browser chooses which layers to actually do? Or is your opinion you should just have a knob saying turn it on?
I think my general feeling right now is that there should be a knob that says turn on temporal layering, turn on spatial layering, and possibly the number of layers in scale factors, which is I think what we have today. And that's it. And then you get some high-level API that allows the application to have control over how it uses layering given different content it might have. But then the actual details about, on any given frame, what should the browser be doing, are all done internally.
Yeah. So right now, like on the screen sharing, if you don't put any encoding IDs or dependency IDs or whatever, you won't get SVC.
You might want to switch to the next slide.
Yeah.
It gives context of what you're talking about. That's it. Okay.
Yeah. So this is an example of actually, we don't have encoding parameters, which is kind of, I think, what Justin was talking about. But these are the capabilities, at least, which tell you how many temporal spatial layers the codec can do. And obviously, if it wasn't a codec that supported SVC, you would have max temporal and max spatial equals 0. So you know that. In the encoding parameters, you would set the dependency if you wanted SVC. So you can certainly, on screen sharing, say you don't want it. And then the question is how you, or what additional parameters you need to kind of enable this auto layering stuff, or I guess some of the other things you mentioned, Justin.
Well, let me give some background here for the people that are just to give some context here. I don't know which slide their encoding parameters is on, but there is an encoding parameter slide. But the idea here in the previous version of the specification, that you would define every single layer. So you define your base layer of your video, and then you define the additional layers for each layer, the resolution or the additional temporal or spatial resolution that you would have in each individual layer. So you have an array of layers, basically, and then you define the properties for each layer. So there's that's how it works currently. So there's the possibility we could just leave it like that, and you say, you still have to do the array, you still have to define every. Okay, so we were in the middle of discussing layering, and just to reiterate, because I don't know what got missed. The current model for doing layering is you have to define each individual layer an array of layers and define what each individual layer means. So there's that extreme where you have to define each layer, or it could be, as suggested on this page, it could be something as simple as a simple Boolean knob where you say, just do layering. I don't care what I want, just do it. And there can be in-betweens too, where there's where you specify I want temporal, this kind of layering, or the number of layerings that I want, but not to define them as an array. So the question we have for the group today is kind of, what's your feeling on that? Is layering an array the way it works today sufficient? Is it not sufficient? Do you want to change it? Do you not want to change it? Do you understand what this is even about?
So, Robin, what's the impetus for making this change? My general feeling about this API is meant for people who know what they're doing. And trying to provide convenience functions or whatever in the API itself is really not a goal.
Yeah, it's not really just about convenience in that there's a functionality here that you can't get any other way. So, I mean, you could certainly do it according to the codec name, like some codec like H264 SVC could just enable auto layering, and then you wouldn't have to put anything in the encoder at all, right? Because it could claim that it's just enabling SVC just by using H264 SVC. But the question is whether, for something like VP8, do you actually can you enable auto layering or not, or do you have to go in and basically have all the detail or basically not use it at all?
Well, even if you're using SVC, you can use, SVC is backwards compatible with H264. You can just have no temporal or spatial layering. And so I think that if you want to have, there are some costs of doing these things. They're somewhat nominal, and in many cases that they're worth it. But I think that if you're going to turn this on, you ought to know that you're turning this on and why. And I think the amount of work required to turn this on to actually say, here, I wanted to have 3 temporal layers, or I want to set up this thing with a structure of 2 spatial layers, is really not asking that much for applications to do.
I think, the question is also, like, say you set up 3. I think you were saying that the browser could decide to do less if it wants to.
Yes. I think the browser should always be able to sort of override those sort of things if it decides that it has more information about what's possible right now.
So in that sense, if you configure any number of layers, could it add layers, like I put in 1 and it goes to 3?
No. And maybe we need to make that explicit to say that, for any given layer you set up, as to whether it's the browser has the ability to turn that off. But I can't imagine the browser adding anything. The browser could only say, due to bandwidth constraints, I can't send both the enhancement and the base. And especially in a simulcast scenario, that would be very common, where you can't even send the enhancement layer at all, so you can only send like the base. So I think that generally the applications say, here's what I want, and it has the bitrate controls that already allow it to specify when it wants it to send the enhancement and when it wants it to send only the base. And if it can't honor the parameters that the developer put in for the enhancement layer, then the browser just won't send it.
Okay, so just let me clarify a couple things. So this isn't my proposal. I may be misrepresenting what the issue is. So if the person who did propose it can speak up at some point, that'd be great. I just want to put a general emphasis here that the ORTC API does have some complex stuff in it to turn on knobs and deal with knobs. So that's because it is a do as I say API, meaning that you really do have full control over what's going on. The idea is not to abstract away in the ORTC API the complexities, because we do fully expect that people are going to write wrappers around some of these complexities to do simple things like saying, I just want layering, go ahead. However, there might be, what I want to ask of the person who proposed this originally, is there a reason why you would need to have adaptive layering that you could not do by, for example, Justin's proposal saying, here's 3 layers, just do up to 3 and that's it. versus, I want auto layering and it has to adapt because of conditions or something like that, which only the browser could know because there's insufficient information. So that's what I'm trying to understand. Is there an actual reason, or is this just for convenience?
Well, no, I think Justin's point was that it isn't clear right now that it's something the browser, the browser could decide not to do. So that was the question. If you configure 3 and the browser can decide, hey, I can only handle 2 or 1, then that's essentially gives you the auto layering that you need. And that would be fine. We just have to clarify it to make it clear that, it's kind of a best efforts instruction and not a command that you either do or don't do.
So the real issue is that the specification doesn't say you can alter what you're doing. It's just that it seems like it's forced upon people that if you say 3 layers, the browser has to do 3 layers, but it really should say it's going to do up to 3 layers and try and do its best.
Right.
Real issue.
Yeah.
Yeah, and I think the other thing that I think Bernard mentions in that bug, I just looked at it, is that the receiver doesn't need to be configured for this. If you're doing SST, the receiver doesn't need to be told, hey, this is going to be an SVC stream coming in. It'll be able to know, at least for VP8 and other codecs that describe all in band, it'll just be able to figure this out. And I definitely agree with that. Yeah.
So we can just come up with some clarifying text that just says, hey, the browser could do less layers, but it can't do more.
Okay. Is there anybody, especially the person who proposed originally, because I'm not sure where it came from.
I think it was me who filed this, but.
Okay. Is there any reason why anybody has an objection to that? Just clarifying text to say it can do up to the amount of layerings that you specify in that detailed encoding layering scheme, and the browser is allowed to do what it wants after that point based upon conditions.
I actually wanted to clarify something. So if we're saying the browser can drop layers, that could be for reasons, local reasons, like I don't have enough CPU to do that, or it could be for congestion control. Are we saying that either of those can be a reason for dropping layers, and the browser can do that, either of those?
My understanding is yes, but Justin, you want to clarify?
I didn't understand the distinction between the two things you just mentioned there.
One is I don't have enough bandwidth to, one is I don't have enough CPU to do all the encodings that you wanted to handle temporal layers. And the other is I'm doing it, but I'm detecting congestion on the network, so I'd like to drop high quality layers.
Okay, yeah, so I thought you said bandwidth both times. So yeah, the CPU thing is an interesting case.
Isn't there two sort of separate contexts here? One is, physically, can the box or browser or whatever, can it physically decode X number of layers versus something where it's some external reason why it can't receive it or can't decode it, or bandwidth restrictions or something like that? And aren't those sort of two explicitly different scenarios?
Well, we're talking about encoding here, I think. What you actually send. Am I correct, Emil?
Either way. I mean,
right.
You're stating your physical capabilities. Whether other conditions do things later is a separate issue, right?
Or it's not necessarily physical. It could be you don't have enough CPU because other things are running. So it's not a physical thing. It's just a thing of the moment. It's local congestion, not network congestion.
Right, but that can change over time. Like I'm running one application and I start running two, or I adaptively, or I get more streams and then my capabilities change because of those things. Is that a negotiation later, or?
I mean, I think it's very hard. If someone starts sending you, a high bitrate sort of, feed, and you can't decode it, there's very little you can do other than try to message the other side and say, please send me less. I think generally speaking, the decode side, there's a lot less ability to influence what actually happens. On the encode side, though, clearly, if you want to send HD, some kinds of HD and then like SD, and you don't have the bandwidth to encode the HD, then we're only going to send the SD. I think that one's pretty obvious. The CPU one is a more complicated set of things because, even just camera capture, might be very expensive at HD. And so what you really might want to do is, drop the actual capture to lower resolution, or you might want to, actually downscale everything and send only a lower resolution feed.
Right. So the question is, would the browser decide, and I think it should actually, but would the browser be the one deciding how to handle that, or would that be open through the API?
I think that the browser would probably, there's no good way for, I think, the application to look at the granularity and say, am I doing a good job encoding this? And I think that the browser, if it has the knowledge of here's the layers the application wants to send, and it knows that it's CPU constrained, it can make those decisions the same way. So having thought about this for about 30 seconds, I think that we definitely want to apply this policy for bandwidth, and we probably also want to apply the same policy for compute. That if we are way oversubscribed in compute, we probably should not be sending things that would push us over the edge. Now the question remains: how would you ever go back up? In the case where you ran some other app that was high compute, and you stopped sending HD. How would you ever start sending HD again? And these are difficult problems. We've wrestled with them ourselves for multiple years. So
like we've run into those scenarios. We have an out-of-band capabilities exchange that we use. So when compute resources go down, we do a capability exchange that is sort of similar to this, to say what our capabilities are in terms of resolution and CPU capabilities. There probably needs to be some mechanism, whether that's not part of the spec or not part of the spec. People are going to want to be able to do those things.
So Chris, by the way, that's Chris talking. And when people start talking for the first time, could you just announce who you are? So Chris, is that when you say you exchange things, are you talking about on the receiver as well?
Yep. Yeah. Both from decoding capability and encoding capability.
Okay.
Great. So I feel like we've talked about this one a bunch. There's probably more stuff to go over. I think generally, the notion, what we sort of, Bernard and I discussed, is the right way to move forward, of that you don't get layering unless you ask for it as an application. But then even if you do, there could be local boundaries, either through bandwidth or compute, that causes the browser to actually send less.
Okay, so if there's no strong objection at this point, we'll continue on that process and do some offline discussion about some more details, for example, issues that Chris brought up onto the list, so that we can hash out any remaining potential issues and discover if we have to add more.
So we had a post by Inaki on October 15th about the robustness features. I think he in particular asked about RTX, but some of the things he asked about also applied to Red and a few other things. So, and Peter replied, kind of trying to explain how everything works. And to summarize it, the FEC capabilities are advertised in the RTC RTP capabilities. So you can figure out what the FEC mechanisms are that are available, and then you can configure them via the RTP encoding parameters .fec. Now, of course, this assumes that we actually have a set of enumerated FEC mechanisms, which we don't really have right now in RTP usage. But in theory, if we had them, we could do it this way. And then the comfort noise, redundancy, and retransmission are included as codecs. So they're advertised within RTC RTP codec capability, and then you set them via RTC RTP codec parameters. Now, in addition to that, RTX is also configured within RTP encoding parameters. So there's kind of these two places where you configure RTX as a codec and then in the encoding parameters. Next slide. So here's a little bit more detail on it. And so for the individual codecs have this RTP codec capability. It includes the name, which would be Red or RTX. For the kind, these things really don't have a kind because you can use them with audio and video. So one of the questions that had arisen earlier is if you do a get capabilities, say with audio, what kind comes back with Red and RTX? And I think the answer is probably the kind comes back that's the same as the one you asked for. So the kind would be audio if you ask for audio, or video if you ask for video. And then there's a bunch of stuff. There's the preferred payload type, so you can set the payload type for Red or RTX that way. And most of the other things in here, except for the parameters and options in the capability, probably don't make sense. Like max temporal layers for RTX or Red doesn't make any sense, or spatial or multi-stream support, stuff like that. And then you get to set the properties in the codec parameters. And that would include things like the name and payload type, which do make sense, and parameters if there are any, and a bunch of stuff that doesn't. And it's mentioned here that the parameters and options at the moment for Red and RTX are undefined. So there's no parameters or options that you get at the moment. I think Peter's post referred to some that would make sense. But that's basically how things work today. Next. Okay, so there are also the encoding parameters, and so we have right now.
Hold on a sec. I think a slide was skipped because you did.
Okay.
Go back one slide, 19.
I went back to, this is the appropriate slide, is it not, Bernard?
It is.
Yeah, slide 20 is the slide we're on right now, Robin.
Okay, so a little bit more detail here. So we have the encoding parameters, and as I mentioned, we have FEC parameters within that and RTX parameters. And within FEC, you get to state the mechanism, the FEC mechanism you want, and the SSRC that FEC mechanism will use. So you'll get an FEC stream. It'll have the SSRC that you specify there. And the RTX will also have an SSRC. And you also get to specify the codec payload type. So for example, you could say that RTX is a specific type. And I guess, well, the codec payload type would refer to everything here. So the FEC mechanism and the RTX would, I guess, use the same, would have a defined payload type. That's interesting. Peter, do you want to talk about how these things are used, the encoding parameters and versus the codec? Peter on?
I'm on. I didn't quite catch the question.
Well, the question is, you configure things like FEC and RTX. You can configure them in encoding parameters. RTX is also a codec. And so you have the codec settings as well that you can use for RTX.
Yeah, so I think the idea here is that in the encoding parameters, you specify whether you want to send RTX for that encoding. And then if it's on, it specifies the SSRC. And then the payload type is chosen based upon the RTX payload type that's associated with the codec payload type for that encoding. So you don't choose the RTX payload type per encoding. You choose the codec payload type per encoding, and then the associated RTX payload type in the codecs is what's used.
Right. So in this case, for the encoding parameters, the codec payload type would refer, for example, to VP8 or H.264 or something like that. And then in the codec configuration, you would have the payload type of RTX. Is that right?
Exactly. Yeah.
Yeah,
And if you had multiple RTXs, it would pick the right one associated with codec payload type.
Right.
So I guess, Peter, you also mentioned that there may be some options and parameters that ought to be defined that aren't.
Well, I think that the way that other signaling mechanisms specify the which payload type an RTX payload type refers to is via a parameter, but we don't call that out in the spec right now. That you would need to do that. Like APT.
Right. Yeah,
But
that was what Inaki in particular was looking for.
So we should probably make a note of that in the spec.
Mm-hmm. Okay.
I'm confused about one little detail here, and forgive me. Is there basically like a VP8 codec, and then there's a VP8 RTX codec and a VP8 red codec and a VP8 RTP codec, or is it just like a VP8 RTX and red codecs, like separate?
Right. So RTX and red are the codecs. I mean, they're the things that have the overall payload type.
But is there a VP? Is it per codec? There's a RTX and FEC version of it, or is there just a codec that's called RTX, red, that kind of thing, like FEC? I'm trying to understand.
So there's no codec called FEC, but there is a codec called RTX and red.
Okay. Sorry, Justin?
I think there will be a codec called FEC.
Oh, okay.
And I think there will be one called red, but those will be one per all. Those will be sort of one. There'll be one of each of those. But for RTX, there needs to be one for each primary codec, because FEC and red actually carry the encapsulated payload types in their payload, so we can disambiguate, multiple codecs that show up in red or FEC. But the RTX stuff does not. And so as a result, the RTX needs to be, a separate RTX codec needs to be defined for each primary codec, and the APT then references for RTX, for again RTX payload type, which primary codec it corresponds to.
So you would have one RTX codec and then multiple of the other. So
no. So let me take a simple example. I've got VP8 and VP9, and with payload types of 96 and 97. Then I've got RTX with payload type 98 with an APT of 96 corresponding to VP8, and then an RTX with payload type 99 with an APT of 97 corresponding to VP9. And then I also have an FEC with payload type 100, and I have red with payload type 101, but those can be used for either VP8 or VP9.
And how do we do the secondary referral thing? How is that defined? So
it's area parameter in the codecs. I forget what specific variable, but in the RTP codec for RTX, it'll have a property saying its APT is for 96 or 97. I think that's an open issue in the tracker.
Yeah, because I don't think we have anything like that.
Because at least right now, actually, we don't really make clear that FEC would be a codec. We just talk about comfort, noise, RTX, and red.
You want to go to the next slide and discuss the problems and stuff, so we can come up with a resolution?
So a couple of issues that have come up. At least at the moment, there's no mandatory to implement or even recommended FEC mechanisms in RTP usage. There will be, I believe, discussion at IETF 91, so that might get fixed. But at least right now, we don't have any FEC mechanisms, even just optional ones. So that's a hole. So the other thing, at least about RTX and red, is they're configured as codecs, but not all of the characteristics make sense. Of course, you can always leave out dictionary attributes that don't apply. In fact, most of them don't. And the other thing is we're missing the options and parameters. They're undefined, as Justin mentioned, so it's not clear how to do some stuff. The other issue which came up when we were talking about kind is these things, FEC, RTX, and red, don't have an intrinsic kind. And so you should probably get them back when you call get capabilities with any kind. They'll come back, and so you do want to return them. But you probably ought to return them with the kind that was asked for, or else it could get weird because you could have mixed values of kind. And if you call receive or something, you could get an exception. So that's, I think, the issues that we know about relating to this at the moment.
Okay, and is there a proposed solution?
Well, so from the FEC stuff, we need an MTI, and so there is a proposal from Varun Singh, which I think will be discussed, so people should read it and comment on it. And then there's a question of whether red and RTX actually should be codecs or should be just attributes and encoding parameters. And I guess that would probably apply to FEC as well if it's a codec. So next. So yeah, there's a question of, is it better as a codec? Is it better just in the parameters? And I think this, Robin, you put this together. This is a...
Yeah, I wanted to illustrate the two possibilities because there are some things like, as I understand it, like red can encapsulate multiple payloads within the same packet. So it's an encapsulating packet. So it's not like you have a one-for-one relationship between a codec and that. It's actually a combined scenario where you have to have multiple pointing to the same one. So there's two scenarios, way to do it. There's one which is you define it as a codec with an unknown kind that we're going to have to define or figure it out. A per codec scenario when there is a relationship where it's a one-for-one, and when you've got an encapsulating one, I'm still unclear as to how that is going to work with our current capabilities-based discussion. So you can either put it into the codec capabilities and define it as a codec, or you could put it in the encoding parameters and define it as a payload type so that you can do a kind of a mapping scenario where you say, it's not a particular codec, it's just this is the payload type to use, and we're going to enable this knob to say that the RTX or FEC or RED are defined, and the payload type is what that points to. So for example, in the case of RED, where it's an encapsulating payload, if you chose 101 as the payload type for it, multiple things pointing to 101 would therefore get encapsulated together. So there's two ways to look at it. I don't really care. I think we should have a discussion as to what it should be and come up to some conclusion as to how it's defined so that we can all be clear and on the same page.
Yeah, I think we may need some example, like a section or something devoted to this with some examples, because one question I had, which I'm still not exactly sure of, is in the case of SVC, if you wanted to apply FEC to just the base layer, can we do it the way things are right now?
I think you can. I think you can because we can have the RTP encoding parameters separate for each layer. So yeah. I think it'll be fine. And I don't think we want to break out red parameters as their own thing. Like red is not something you really do explicitly. Red is something you do because you're trying to achieve FEC. And so I think that the stuff that's on the slide, I don't think this is the way we want to go. I think we just need to make sure that, for the scenarios that we want to support, which is sort of audio FEC via red or video effect of like the base layer, we have the right things to do that, and the right way to support RTX when there's multiple codecs and then multiple RTX payload types that need to be used with the right APT stuff. We have all the right sort of properties and stuff that hook that all together. And so working through a couple examples, I think will be very helpful there.
So are you saying, Justin, that you would never use red with video FEC?
I mean, it could be used with video FEC. You could have, with the sort of thing where you stitch together, a payload on, a FEC payload on an actual regular payload. But usually we're going to send it, I think, with a separate SSRC. And so I don't think we would actually do that in most cases. We should look at, we should be taking the input of this draft, that is being written up for Honolulu on like the way to do FEC for RTC Web as input for what the API requires. And I think that it'll give the guidance on, okay, here's where you use red and here's where you do use like FEC on a separate SSRC. Yeah.
So I can definitely see maybe even a little subsection or something that describes all this, given how much confusion we just exhibited.
It's complicated. It's certainly complicated.
So this is part of the problem, is because we lack some really good examples, I think, that it's unclear as to how all these things work together and with the payload types and the capabilities. And also for the latching rules to define how they work, we do need to have those examples so we can make sure the latching rules make sense too, because otherwise we're going to have random SSRC comes in. What does it belong to? Where do we put it? Is it an RTX? Is it red? What is it? Right? So.
Yeah, so we're talking through some of the latching scenarios where with the MUX ID, we know how to get the FEC stream to the receiver, but then there's a question of, does the receiver know that it's an FEC stream, or could it get confused and think it's media?
Yeah. So would Google mind, since you guys seem to know this really well, to come up with some examples around this? So so that we know how to define it in the encodings as well as in the capabilities?
Well, the first thing we need to do is finish this document of the actual FEC mechanism stuff that Bernard points out is missing. So that's like our current top priority. But once we have that, I think we could come back and say, how does that document then inform this API, and try to work up, like, here's what you would do to do audio effect. Here's what you would do to do video effect plus RTX. Here's what you would do to protect the base layer. And I think that would be pretty straightforward.
Yeah, it kind of ripples through, right? Because it affects the FEC, obviously, and then it affects Red because Red uses it. And yeah, RTX has the same question, right? You can just wanted to use RTX on the base layer. So,
right. So I mean,
oh, okay, that's cool.
Yeah, that's basically suggesting adding like an RTX payload type to the RTP codec parameters.
That was me. It's not example code. It's more like if the only purpose of having RTX in the codec list is to say I want this RTX to refer to that payload type, why don't we invert it and say this payload type can optionally have this RTX payload type? The only problem is if we would ever want two RTX payload types that point to the same base payload type, but I don't know why you would ever want to do that.
Yeah, I mean, the problem is like we ended up then treating FEC then differently because we wouldn't have FEC in the RTP codec parameters like FEC payload type, because then that would be like duplicate. So,
but FEC is different in the sense that there's only one. This is something where you have to have like multiple.
Yeah, I know, but then like you have to have FEC. The FEC payload type needs to be signaled in a different way than the RTX payload type, unless you want to say that the RTX payload type and FEC ones are signaled just without the APT stuff, and then the APT is done by this thing. But I think that we're actually probably running out of time on this one, so we should probably just figure out a different time to talk about this specific part.
Agreed. Okay, so now we're up to date into what's going on, and people understand that this is really complex. We'll get some examples together. And if anybody has any proposals, please take it to the list and let's argue it out and get it detailed. Okay, next issue.
So issue number 155, and this was, I think, submitted by Gianon. And so basically, I think this is an artifact of some of the changes we made between the transport and the gatherer. So formerly, onLocal candidate was a method of the ICE transport, and to create an associated RTCP transport, you would call RTP transport.create associated transport. And as a result of that, because onLocal candidate was a method of ICE transport, the browser always knew the component when it was gathering the candidates, so it would know, okay, this ICE transported as a component of RTP, or this one is RTCP. And it allowed the browser to optimize the RTP and RTCP turn allocations, like, for example, using a single TCP port. When we moved onLocal candidate to the RTC IceGatherer, that information was no longer available to the browser until you would call ice.start, because at that point you would associate a gatherer with a transport, and then you could know, hey, this gatherer has an implicit component of whatever the component of the transport was.
I don't understand what this is saying. I don't understand like how you could have a single TCP port for a turn allocation, because every turn allocation is per 5 tuple.
But you can allocate multiple turns within the same TCP connection.
You cannot do that.
Used to be able to do that.
No, you never could do that. It's always per 5 tuple. It's like a key way of how turn works.
Gianon, since you submitted this, you want to talk to it?
Is he here?
It doesn't seem to be here anymore.
Oh, okay.
Well, it's kind of hard to discuss unless we know the exact issue here, because
So I had a fairly long email discussion with him, and basically, I think it came down to I was suggesting that this is out of scope because the only use case that I could see was one where you're talking to some legacy system that expects the RTP port to be only one different than the RTCP port, and Like that just seemed out of scope for
Yes. Seriously.
ORTC 1.1.
It's definitely, we've already decided that one. It is definitely out of scope for the +1 issue.
Yeah, because I mean, basically something like that, right? Wouldn't do ICE to begin with. So what's the point?
Yeah. The only issue I could see is if there was an allocation optimization scenario that you might want to have, but if there isn't, then there's no point, in my opinion, to even considering a move between the two objects, between moving crate associated from the transport to the gatherer. I don't see the point unless there's an allocation optimization.
So I never really saw any use case that was in scope.
Well, then, does anybody have any thing to add here? Because otherwise, I think it's a no-go unless they can really explain what the issue is beyond the +1, because that's already been.
I mean, as Peter has said, the application knows whether it's RTP or RTCP, so it can never be a signaling issue, because it can always know and just say what component it was when it signaled the candidate. So it doesn't come up there. It can only be something the browser would need for the purpose of gathering the candidates. And if we can't come up with a reason, then there isn't one.
Okay, sounds like unless somebody has something, please speak now. Otherwise, I think it's a no-go, and we can revisit if there actually is an issue beyond the +1 port issue, which is definitely not an issue. Okay, so
I don't think we need to talk about that then.
nope. Okay, so wanted to discuss people about implementations. We're getting into the nitty-gritty details of how individual things work, and we wanted to discuss implementations. We have an open source project which we're pursuing mostly for the mobile space at this point, a C++, a wrapper around the Chrome, to give the ORTC API around the Chrome interface that's already there, targeting mobile. But wanted to talk about browser implementations and if any other implementations that people are doing or interested in, or projects they want to work on, or anything regarding ORTC that people want to do. Love to hear about it today.
Okay, maybe this could be the time for me to talk. That's why I joined this call, and I was waiting for the call for implementations, actually, to express our interest. With the Ocean Corporation, we are using WebRTC 1.0. And the main question is, yes, with ORTC, we could support then Internet Explorer. So the question is, we could invest in implementing ORTC on top of what we have done. But if the difference is just supporting a new browser, we really do not see a business opportunity. If this implementation could give us more advantages, then yes, we are interested. The real thing is that we are not clear what are the advantages we could get deploying ORTC rather than WebRTC. So maybe if some of you could help in understanding what we could get out of ORTC today that we do not have on WebRTC, that would help us understand if we could invest in implementing it.
Okay, I think there's probably going to be multiple responses here. So
absolutely.
So I think we should probably try and queue the responses via chat might be appropriate. So who would like to be the first to respond to Claudio?
I'll do an initial thing. I'm sure Justin will have a comment on this one too.
Okay. Robin, go ahead.
I'm speaking inappropriately on your behalf, but I would just say that first of all, it's not an either or scenario. WebRTC 1.0 is a higher level API on top of what already exists underneath the hood for ORTC, and we're just re-exposing lower level objects and do, as you could say, scenario. The reason for doing it really comes down to that there are scenarios that are made extremely difficult with the WebRTC 1.0 API. And there's also scenarios where you need a lot greater fine-tuning control over the knobs to be able to really control your scenarios. So when it comes right down to it, the business case has to do with the scenarios that are not easily done with the current WebRTC 1.0, and I'm sure Emil, not that we really want to have a dissertation on this, can speak to the complexities of even doing this Jitsi bridge with the 1.0 API and the complexities he had to deal with to do that. And also with simulcast scenarios, a scalable video codecs, and everything related to that. So it's not an either or. It's that. It's like that. So anybody else can jump in after.
Great,
that.
Thanks, Robin. Justin, did you want to say a few words?
I didn't really even fully follow the premise of the question, but like I agree with what everything Robin just said there. That these are sort of complementary as opposed to competing efforts, and that the main value should not be seen as like supporting another browser, but providing like the detailed control surfaces that it makes it easier to do. As Robin said, things like this Jitsi bridge, or even like sort of applications that are considerably different than a typical video call.
May I answer on this one?
May I interrupt you just for a second, because I think we can talk about the advantages of ORTC for quite a long while, but wasn't the question about implementations and not using applications?
Yes.
Right. Yeah, I mean, I think, ORTC Live is a C++ wrapper for ORTC. The kind of motivations are, you could be creating your own browser, or you could be for mobile use, which is what ORTC Live is about, or there's potential server uses like within Node.js. Those are the kind of main things that come to mind. Maybe people have other ones.
Thanks, Emil. Thanks, Bernard. Claudio, do you need further clarification here?
Well, yes, maybe this is not the right moment to discuss this, but it is the message I want to land is that it's not real clear to us why we should quote unquote evolve into an ORTC implementation from where we are today, because we do not see a clear, maybe because we do not see that, but we don't see a clear advantage in investing today, implementing ORTC, where we basically got everything we need with the current implementation. That's why I was asking you, hey, tell us, convince us to move into that direction, because we are not prepared to really understand what we can do better.
So I'll just speak to that very briefly, because it really isn't an argument in my opinion. There are certain people who have certain use cases that can see WebRTC and go, oh, ORTC makes a lot of sense compared to the WebRTC 1.0, and it's not an either or. WebRTC works great for a lot of people. I'm not going to debate that isn't even up for debate. We all agree with that. It's just a lot of the scenarios that people have, they go, ooh, it's really complicated here to do it this way. For our case with the ORTC lib, the reason why we're interested and the reason why we're wrapping the Chrome implementation is because we want to have an easy access to an SDK that allows us to talk to the browser, the existing Chrome implementation on the browser, from native mobile applications. That's our motivation to do it. So we're taking the Chrome implementation, it works great. We're adjusting it for our mobile scenarios to produce the ORTC API, because we need personally that kind of API to do a lot of our scenarios we want to do. So that's our motivation for doing ORTC lib. Now, other people might have different motivations when it comes to Node. Like I've heard some discussions about potential Node implementation for server and doing stuff there. They have their own scenarios they want to achieve. So there's a bunch of different scenarios that might be interesting. And then obviously having ORTC eventually in the browsers, I don't know. I can't speak on Internet Explorer's behalf, nor can I speak on Chrome's behalf or Mozilla's or anybody else's, what their long-term goal is and what they want to do, but I'd love to hear that as well.
Okay, Robin, we're running low on time here, and we have an actual implementer that wants to say something. So Bebop, go ahead. And I think you're muted, Bebop, so unmute yourself.
Anyway, thank you for the answer, for all the answers. I would say maybe we will be more interested than in migration scenarios later on.
Yes, thanks, Claudio. I think that it'll become more evident as time goes on as well. There are some people that are implementing early based on the API that see obvious merit in doing that. If it's not as apparent to you, it might be just a wee bit too early, or maybe you need to do a little bit more investigation into the specification in the API. And we're happy to have conversation offline and go through some of this stuff with you as well.
Thank you.
Guys, do you hear me?
We hear you now, Bebop. Go ahead.
Oh, cool. Okay, so first of all, thank you very much for doing this. Bebop from Yorio, Los Angeles. Well, in our case, we are perfectly convinced that ORTC is going in the right direction. We're actually developing a project that it's basically a giant video chat with moderation to allow people go on air in live broadcast in national TVs. We have different national TV clients, and we think we can be mutually useful for this project because, one, we want to support it, and we want to also implement it in a way that can be basically available to all the large consumers. So we are very open to discuss what is missing inside the ORTC development in a way to speed up the process and to bring this fantastic technology to the world. So you have my support, guys, and in the name of our company, we strongly recommend other companies to jump on board.
Awesome. Thanks, Bebop. Appreciate those comments. We're now out of time. We should probably take a look at the remaining slides. Are there any questions for the community group at this time? I think we've heard one from Claudio. Does anybody else have any comments quickly? Okay. Is there any comment from Google and or Microsoft regarding progress? We've seen a recent pull request regarding sender receiver, so that was great to see. Can you comment on what we can expect in the future, Justin, in terms of the level of integration and timing around some of that? I'm not sure how much of that is public or would be public that you could speak about.
Well, what I have hopes for in the short term is that we'll land this pull request in the next week or so. Then in 2 weeks is the W3C meeting in Santa Clara, and there we'd like to try to get agreement on some of the other pieces surrounding the RTP sender and receiver, like the DTLS transport and the ICE transport, which we introduced back at the DC meeting, and there was general interest in, but there were just a little bit of people trying to get their heads around it. And so once the initial pieces land in the spec, I think we'll have the ability to get these other sort of pieces in as read-only components, as we previously discussed. Peter's had a bunch of ideas about how we can bring in some of the other pieces, like capabilities and that sort of stuff, as sort of evolutionary steps from there. And I'm hoping that we can actually present that to give a clear indication to the working group as here's where we want to go next with this. Here's the other pieces we wanted to try to incorporate into the 1.0 spec coming in from ORTC. And in 2 weeks, that's not too far from now. Hopefully we can get consensus to move forward with that and set ourselves up for a general incorporation of a lot of the work that we've done in this working group to actually sort of be part of the official sort of WebRTC spec.
Okay, thank you, Justin. Is there anyone from Microsoft that can speak to their work here and what we might expect next, if some of that can be made public at this time?
Is Shurjan on the phone?
I see him 3 times. 4 times.
He's really here then.
Yeah, well.
Maybe he's crashed.
I think Shurjan, if he were to say anything, would say that stay tuned for a public statement from from IE on their plans concerning ORTC.
I think Shijin's trying to talk, but we can't hear him. Shijin, have you muted yourself?
He said I can speak for him, but
Okay.
but all he was prepared to say is that you know, stay tuned for some public information on IE's status on this. So look at status.modern.ie, and I believe they will make a public communication about it in the real soon now.
Do you have any idea in time frame? Because we've all been watching curiously.
Before TPAC.
Before TPAC, you said?
Yes, before TPAC, you should see a public statement from IE.
Great. Good.
Brilliant. Thanks, Michael. I appreciate you speaking on behalf of Shijin on the Internet Explorer team there. And on behalf of Hookflash, we're working diligently to try and make some advancements on the ORTC library as well. If anybody's interested in taking part in that, we're more than happy to talk to them, and they can send an email to Eric, E-R-I-K, at hookflash.com to have some conversation around that. If you're interested in helping sponsor, or if you want to contribute, we'd love to hear from you. Is there anybody else that would like to speak out at this point about implementations, ongoing, new, that haven't already spoken?
Or anything.
I'd just like to issue a quick encouragement to all implementers of ORTC browsers that this is something that would be greatly appreciated. So I join the other people that have expressed that in such an opinion. And thank you everyone for doing that. And thank you for the work on this specification.
Thanks, Emil. Appreciate your comments, and it's been a lot of work, as you are well aware, and we all feel the same way. This has been a work of love, so we hope to continue that. And with that being said, I think that wraps up the meeting. If anybody has any further questions or comments, please take them to the list, and we can look forward to another one of these in about a month. It's been a while since the last meeting, and the reason is there was a big summer break, and there was a bunch of work left to do on the spec, which was done recently, so we should be in good shape for another meeting in about a month's time. Thank you all for joining, and we'll see you online.